Welcome to Managing a Windows 2012 Server Environment. I'm your instructor, Robert McMillen, and we're going to be using the book called Inside Out Windows Server 2012, written by William R. Stanek. This is Part 4, Lab 1, Managing a Windows Server 2012 Networking and Domain Systems. In this lab, we're going to be discussing TCPIP and DHCP. TCPIP comes in version 4 and version 6. We've talked about this in previous labs, and we've talked about how to set an IP address on a server. But one thing we haven't discussed is how the networks actually talk to each other. So that's what we're going to concentrate in this particular time. As I mentioned earlier, version 4 has only 4 billion IP addresses, where version 6 has so many zeros in it. All I can say is that there's 80 trillion IP addresses for all 7 billion people on the earth. So the difference is that version 4 uses 2 to the 32nd power for its addressing, and version 6 uses 2 to the 128th. So setting up TCP/IP on the server, all servers starting with Windows 2003 could use IP version 6, and on 2012 you see that it's enabled and running both protocols on the 2012 server. So in order to talk to each other, you have to be able to be on the same subnet. So let's talk about how you can get on the same subnet. Well, here's TCP/IP. TCP is actually a protocol that is over IP. If you think of TCP as the driver and IP as the car, then this makes a lot more sense. There's a lot of different protocols that can sit on top of IP. TCP is one of them. Another protocol we use on the internet, but it's not talked about as much, is UDP over IP. And there's also GRE over IP, which is used for some types of VPN tunnels. So TCP, or Transmission Control Protocol over Internet Protocol, is basically a connection-oriented protocol, which means that when a piece of data goes from one computer to another, the computer on the sending end makes sure that it reaches the receiving end using a series of handshakes. And once those handshakes are complete, that the data has been sent and acknowledged, or called an ACK, then that means that TCP can now rest and look for the next piece of data to send. It's a slower protocol than UDP, but since it's connection oriented, you know that the data got there. UDP is different in that it is connectionless. It's much faster, but it doesn't care whether or not the data actually ended up on the other end. So you don't really want to use that for business. It's fine for gaming and some other things where you need to send out large streams of data where it doesn't matter if some of the packets get lost. So TCP is split up into two different types of subnets, both routable public subnets and non-routable private subnets. So these public subnets is basically any, at least on the version 4 addresses, are any number from 1 up through 240 for the first address. And then the rest of the addresses can go up to 255. So I'll show you what that means. But the address 1.1.1.1 is a routable public subnet. So is 142.5.7.8. So all those mean is that you can have a website or a server that's sitting on the public side of things, that's reachable from your own computer from anywhere in the world, and it will have one of those addresses in them. So on the private side, you basically have only a few options. These subnets, the 192.168.0.0, 172.16.1.0 through 172.16.31.0, and anything that starts with a 10 are non-routable. So on the inside of your network at your home or your business, it's going to start with one of these three different subnets. And the reason for that is because they're non-routable. You are not going to have any kind of routable IP address on the inside of your network that anybody can get to when you're on these subnets. Now, you may host a web server and it may start with a 192.168 address. So how does that get out to the internet? How do you host that web page or that blog or that wiki that you have on that web server if you have a non-routable IP address? Well, that's simple. your firewall does what's called a translation. It translates the public IP address given to you by your internet service provider to a private IP address, and it hides the actual private IP address from the rest of the world. This is a good thing. This is something that you want to happen because it keeps your server safe. So that's the difference between the public and the private. Now, the next thing is subnet masks. Now, subnet masks are everything when it comes to being able to communicate with another server or with another computer. So the subnet mask masks the network from the host. Now, every single computer, tablet, or phone is a host. The network is the first digits from left to right that it starts with. So let's talk, for instance, about 192.168.0.0 with a subnet mask of 255.255.255.0. So what that means is that this is the network side of this is going to be 192.168.0. So if you want to communicate with the server, let's say we put the server on the .1 address. If you want to communicate with the server on .1, then your first three numbers on your computer have to start with 192.168.0. Now your host has to be something other than one. You can't have two hosts with the same IP address. It's like having a house I'll call 123 Main Street right next to another house called 123 Main Street. That's just not allowed. So the host, on the other hand, has to be a different number. So you're all on Main Street, but you have a different house address. So that's how that works. This is the subnet, and this is the host, which is your computer, your endpoint. So it's masked by using these three 255. So 255 three times masks these three here. Now let's just say, for instance, that we're going to change the mask to be 255.255.0.0. So now we'll put a space between there. Now our network and our hosts are split this way. So the first two are now the network, and the last two are now the host. This gives you a lot more hosts. So if you have more than 254 hosts, then you'll want to split this by changing this third octet from a 255 to a 0. So instead of having just 255 hosts at 2 to the 8th power, we now have 65,000 hosts, which is 2 to the 16th power. So you can have 65,000 computers on this network. In order to communicate with that network, all computers must start with a 192.168. If they have anything else, they will not be able to communicate. So we can take that one step further, and we can go 255.0.0.0. And now we say the network is 192. It means you have to have 192 in order to communicate, but the hosts can start with anything. They could be 192.0.0.1, 192.0.1.1, 192.12.1.1. It doesn't matter. Anything to the right of the 192 is now fair game all the way up to 255. So that is how you route TCPIP. You have the network side, which has to be the same, and the host side, which has to be different. Now, you have several tools that you can use in order to make sure that things are working right with your TCPIP. You have ipconfig, which basically just tells you what the IP address is of your current computer. It also allows you to do refreshing, releasing, renewing of IP addresses if you like. Netstat, it tells you what TCP ports are open, so that way you can tell whether your firewall is doing its job or not, or if it's misconfigured. If you have a port that you don't want open and it is open, then you could be hacked. So that's one way that a lot of people get hacked, is because their firewall is not configured right. Then you have ping. Ping just basically says, hey, can I communicate with this other computer? So if it says no, then you know that either your subnet's wrong, your subnet mask is wrong, your IP address is wrong, or there's some physical communication link that is broken, such as maybe somebody forgot to plug the cable in. Traceroute tells you how to get out to a different location. So it tells you all the different routes that it takes from point A to point B. So let's go ahead and start with that. Let's start with ipconfig. If we do ipconfig, config, enter. It tells us that this is our IP address, 192.168.15.2. Our subnet mask is 255 times .0, so we know that this is the subnet and this is the host. Our default gateway is 192.168.15.1. That's my firewall. So to go out to the internet, it knows that it's got to go from 2, which is itself, out to 1. We also have the version 6 addressing as well, which we're not going to get into in this particular video. So if I want to see if anyone else is out there, I'll do a ping, and I'll just type a known public IP address that's out in the world, and you can see I get a response. If I try to ping something where there is no response, then it will give me a timeout. So let's try to ping an address that I know there's no address. And it should say timed out. There it is, request timed out. It will do 4 of those unless you do a Control-C to stop it. All right, so we did ipconfig, we did ping. Let's go ahead and do netstat. So if we do netstat pipe more, that way it just does one page at a time for us, we can see all the different ports that are open on our computer. So we can see that we're connected to an HTTPS port at another location. Shows connections as well. If we do a -AN, it gives us even more information. Shows us the individual ports that are open, although not necessarily connected, but you could say they're just listening on these ports. Established means it's actually communicating with that particular device. So you'll see established, you'll see listening. So we may say, oh, we're listening on port 445. I may not want to do that. So I'll go into my firewall and I'll tell it to not listen on port 445. And the last tool I'm going to show you today is the traceroute. And traceroute tells you how many hops it takes from point A to point B. You can never go more than 30 hops. So if it's taking a long time to get anywhere, then you'll want to do a traceroute, and then you'll type in the IP address, and then you'll see how far and how long it takes to get there. So if you're, for instance, using a DNS server that takes 20 hops to get to its destination, then browsing the internet might be a little slow. But if you pick another one that's only 3 hops away, then you'll get there much faster. So far we're seeing, here's the responses just like in a ping, and then here's the actual destination of all the different places from point A to point B. This is a trace, so all these different ones are routers from here all the way to the end, and it finally got to the end, and it took a total of 12 hops, which is a reasonable amount of time. DHCP, let's talk about Dynamic Host Control Protocol. DHCP is the protocol that's used to automatically assign IP addresses to computers, so that way you don't have to have all your computers have a static IP address on them like you do on the server. In 2012, there's an additional option. It's for redundancy. It allows you to have 2 servers both running DHCP, and you can set them up to load balance, so if one server dies, then the other server picks it up, and that way if you decide to reboot one of your servers or it crashes that's running DHCP, the backup DHCP server will automatically kick in, and it will allow you to, it will feed out IP addresses to all the people in the office for you. So let's go ahead and take a look at DHCP. We can see it's installed here on Server Manager. And so if we click on that, you can see a little bit of information about it, but the actual manager itself is under Tools, DHCP. So here's the DHCP manager. And we're going to go ahead and expand that so we can see what's going on. And you see the IP4 and IP6. We're still mostly using IP4 internally. Some places are using IP6 on the outside, but very few use IP6 on the inside. So let's go ahead and choose to create a new scope. We'll just call this the test scope. And we'll start with 192.168.0.150. And we'll end at 192.168.0.200. We can see the subnet mask is 255 times .0, so we know that our subnet is 192.168.0. Length is 24 bits, and that's because each one of these octets are 8 bits. So 8 plus 8 plus 8 equals 24. 2 to the 8th power is 256. The number starts at 0, so 0 through 255 is 256. Exclusions basically says, hey, there are certain IP addresses I don't want you to hand out because maybe some static IP address is on there. So we'll do .125 through 130. We'll click add. So those IP addresses will not be handed out to anyone. And we may have gotten something off on the range here. Oh, 150 through 200. So we have to do, we'll do 165 through 170. We were outside the scope there, but now we're okay. All right, the default is going to be 8 days. That's how long the least duration is going to be. It's a good idea to change that to 1 day, because otherwise when devices disconnect, they hang on to that IP address even though those devices are no longer there, and you tend to run out of IP addresses if you let them go for 8 days. All right, so we want to configure scope options. Scope options allows you to put things in like the router or default gateway. This is the way out to the internet. This is your firewall. So we'll say that is 192.168.0.1. Without that, you can communicate internally, but you can't communicate with the rest of the world. DNS servers. So you can put in your parent domain, put in test.local is the name of our Active Directory domain. And then the server name that we're going to put in for DNS is this particular server, which is already listed in there. So we'll go ahead and click next. Win servers, this is used as older technology. We no longer use this because it broadcasts a lot. If you happen to have Windows clients that are older than Windows 2000, such as Windows 98, 95, then you would add a Win server. We don't have that. We'll go ahead and activate the scope now. And now we see our scope. Now, here's our address pool that we just set up with our exclusions. Here's our address leases. So far, no one's connected to us. Here's our reservations. Now, reservation allows you to say, hey, I want a computer or a printer to always have the same IP address every single time that it boots up. So that way, everybody knows how to reach it. We can call this one, we'll call this one printer, and we'll give this one a 192.168.0. We'll say 171. Now the MAC address is the hardware IP address of that particular device. So if you want to know what the MAC address is, then you can ping it by IP address to start with. So if it is already at 171, then you ping it, and then you do what's called an ARP-A, and then it tells you what the MAC address is. This is the MAC address. So this isn't the right MAC address for 171, but just for example purposes, we'll go up here, we'll copy it, go here and paste it in. Okay, now we'll go ahead and click, the supported types are both DHCP and BootP. BootP are non-Windows devices. Go ahead and click Add and close. So now we have a reservation, so anytime that printer boots up, it's going to get the IP address of 171. Makes it easier to share that printer. Next thing we have are scope options. These are the options that we created when we created the scope. It's just rehashing what we already did. And you can also put in policies now if you'd like, which we're not going to do. And server options are a little bit different. Server options are if you have multiple scopes, but you have everybody using the same DNS server, then you can set the server option to use the one DNS server, and it'll override any settings in any other scopes for that particular setting. So that way you don't have to put the DNS server in every single scope. If you have 20 scopes, you can just put it in once under server options, and it'll automatically assign it to everybody. You can right click on IP version 4, go to properties, and if you go to the advanced, one tip I'd like to give you is to click on the conflict detection attempts and change that to 1, so that way it'll try to ping an IP address before assigning it. If it finds it, then it won't assign it, so you don't end up with an IP conflict. An IP conflict is when 2 or more devices have the exact same IP address. All right, so we discussed TCPIP, DHCP, and in our next lab, we're going to talk about the domain naming service.